Okay, so with that principle, we're going to go through with every blood type to see what they could be. Because again, we don't know what the patient is until we perform this test. This is how we determine a patient's blood type. So again, we have the forward grouping up here with our anti-A and anti-B, and then our reverse grouping with our A1 cells and B cells. And this is all four of these tubes are all set up at the same time. So no matter who the patient is, no matter what their blood type, we're going to do the exact same thing, and this is what the results should be. So we'll take one tube with anti-A as the reagent and take the patient's red blood cells. Take another tube with anti-B with the patient's red blood cells. Another tube with A1 cells and add the patient's plasma. And then take B cells and add the patient's plasma. So we just did the group A blood type. Let's do it again. So if we have a group A blood type, we're talking about what antigens are present on the red cell surface. People find this part really confusing. Remember that their blood type is telling us what antigens are on the red cell surface, and we're using antibodies here to help determine what that is. So this is our known, and then this will be our unknown antigens. So if we have a group A person with A antigens on the red cell surface, those A antigens should react with anti-A reagent. So we're going to get a nice strong 4+ reaction. And then those same red cells have A antigens on them, so they should not react with any anti-B anti-sera. So you'll see a negative reaction. And then we take their plasma, which if they're group A and they have A antigens on their red cell surface, they should have anti-B in their plasma. So we'll take the patient's plasma, add it to A1 reagent cells, and their plasma to B reagent cells. So if they have anti-B in their plasma, they should not be reacting with A1 cells. So you'll see a negative result there. And then their anti-B that's in their plasma should react with the B cells. So you'll see a 4+ reaction there. And like I said, that's the standard reaction for the forward and the reverse grouping for a group A individual. Now, if you do group B, you guys could probably just pause it right now and try and do it yourself. So if you want to do that, just pause this video, try and fill out group B, A, B, and group O on your own and see how you make out. And then start the video again and see if what I write in matches what you guys just did. Okay, so group B, we know that a group B individual has B antigens on the red cell surface. So when we take their red cells and we add it with anti-A and anti-B, B antigens should not react with an anti-A reagent, so you should see a negative result there. If you take those same red cells and you mix it with anti-B, those B antigens on the red cell surface should react with anti-B anti-sera. So you'll see a 4+ in that tube. Again, this was unknown until you shook your tubes and you recorded your reactions. And then you take your data and you interpret it into a blood type. So this is what you would do in the lab. If you were working on your own, you would record these reactions and then you would interpret what their blood type is. So that same group B person, we know if they have B antigens on the red cell surface, that means that they should have anti-A in their plasma. So if we took their patient plasma from that example, added it to A1 cells, and then added it to B cells in 2 different tubes, their anti-A should react with the A1 cells in the reagent here, so in this tube. So a group B individual who has anti-A in their plasma should have a 4+ reaction here. And then their anti-A that's in their plasma should not react with the B cells because it's anti-A, so you'll have a negative result there. And then group AB, you guys can probably guess, they have they have A antigens and B antigens on the red cell surface. So if you took a patient's red cells and you added it, and they're type AB, and you added it to anti-A and anti-B, and you shook both those tubes, you're going to see a reaction in both. They have A antigens, which will react with the anti-A, and they have B antigens, which will react with the anti-B. So you'll see a positive in both of those. And you guys remember, if you're group AB, if you have A antigens and B antigens on your red cell surface, neither one of those are foreign to you. So that means your plasma does not have any naturally occurring ABO antibodies. They don't, because the A and the B antigens are on their red cell surface, so they're not foreign. So they can't produce an antibody to something that they already recognize. So if you take the plasma from a group AB individual and you add it to A1 cells in the reverse and B cells in the reverse, their antibodies, they don't exist. They don't have any ABO antibodies. So there's no antibody there at all. Like, yes, we added the plasma, but there's no ABO antibody to react with the A1 cells or the B cells. So they're going to have a negative result in both of those. And then finally, a group O individual, they do not have any ABO antigens on the red cell surface. They just have that H antigen, which we talked about now in the last PowerPoint. So they have the H antigen, but this is anti-A and anti-B, not anti-H. So there won't be anything to react with. So if they only have H antigens on the red cell surface, if you take their red cells and you add it with anti-A, there's going to be a negative result. And if you take their red cells and add it with anti-B, there's going to be another negative result. There's no AB antigens present on a group O red cell. But because they're lacking both A and B antigens, both of those antigens are foreign to them, which means they will have naturally occurring anti-A and anti-B in their plasma. So when you do the reverse, you'll take their patient plasma and add it with A1 cells and B cells, and they have naturally occurring anti-A and anti-B. So their anti-A that's in their plasma will react with the A1 cells. So you'll see a 4+ here. And then their anti-B that's naturally occurring in their plasma will react with the B cells. So you'll see another 4+ here. So this board right here, if you can see the whole thing with the reactions at the bottom, this board, these reactions are how you're going to interpret the patient's blood type. So there's 2 steps to doing the type and doing the ABO portion, like the typing of it. There's 2 steps. There is, well, you can call it 3 steps, I guess. You have to do the forward and record the reactions. You have to do the reverse and record the reactions. But then after that, you have to interpret what those lab results mean. So it's good enough for you to add anti-A and patient red cells and add anti-B and patient red cells and then do the reverse properly. It's good that you can follow those directions, and then it's good that you can shake the tube and record the reactions. But if I didn't give you these blood types here, would you understand what those reactions mean? Because in the real world, you don't already know what their blood type is. I gave it to you here to show you what the reactions look like. But in the real world, this is all you get. You add your reagents and your patient sample to each tube. You record the reaction. So if we look at just the top one here, you record the reaction, and now you have to interpret what those results mean. And if you can't interpret this, then you don't understand blood typing. You won't be able to determine what their blood type is. So it's really important that you understand what you're doing in each step in order to get a result and then interpret that result. So if you see a 4+ with anti-A and you do not see a reaction with anti-B, you have to be able to understand that that means that they have A antigens on their red cell surface and no B antigens, which makes them group A. And then you have to be able to look at the reverse and say, okay, does it make sense with what I discovered in the forward grouping? No reaction with A1 cells, which means they don't have an anti-A, but a positive reaction with the B cells, which means they do have an anti-B, which does correspond with them having A antigens. If you have A antigens, you have the opposite antibody. So yes, this does make sense. They are group A. And then you have to be able to do it for each blood type. So you never know what reaction you're going to get until you record your results, and then you have to interpret those results. So on a test, I could easily give you something that looks just like this. Here's a bunch of results. Now, and here's the reagents that we used. Now tell me what each blood type is. Interpret what all of these results are. So for the first line of results, what's the blood type? For the second line of results, what's the blood type? And I'll make you do that on a test. And that is ABO testing 101. Like, if you don't know how to interpret these results, you won't be able to understand blood typing. So it's really important that you guys get this down.